welcome to this Sigma Metalytics video. Today we've got something a little different for you. We were sent a whole box of different coins and bars that we're going to test and see if we can find any fakes in there. I don't know what size of coins and bars we've got, so I got our Pro device out because that can cover just about everything that someone could have sent us. The two onboard sensors should be able to cover most of what we see. If we've got some small pieces in cases, then the wands will be good for those. And then finally, if they send us any really big bars, that external bridge will be able to test, 50, 100 ounce pieces. So let's check out what we were sent. First up, we've got a 1 ounce silver piece. Looks like it's from the Australian Mint. Should be pure silver. It's in its capsule. Then we've got two silver maple leaves. I suspect one of those is fake if they sent us two of them. We've got a 1/4 ounce gold piece from Monarch Precious Metals. We're going to see if we can figure that one out. We've got two 1 ounce gold maple leaves. And it looks like one is from 2002, one's from 2004. Again, I suspect one of these is fake. We got two Krugerrands here. One from 78 and one from 88. We're going to see if we can figure out if either or one of those is fake. We got an interesting little bar here. It is a gold piece, but it even says on it 1 troy ounce, 100 mils fine gold clad. So we know this one is gold plated, but we're going to see what that looks like on our device. We've got a silver Pamp Suisse 1 ounce bar here. It's in its assay. Unfortunately, that doesn't always mean that it's a real piece, so we're going to test it. We're not going to take it out of its assay. We are going to test it and see if we can figure out if that one's real or not. Here we've got looks like an 1875 90% silver US coin. So we can definitely test that. It'll be interesting to see how that reads on our device. We've got a big one here, a 5 ounce silver panda from 1994. It feels quite large in my hand. We're going to do some testing on it, see if this is a genuine piece. We've got a 10 ounce silver bar from Provident Metals. And we're going to see how that tests. So I might show off how the small wand interacts with some of this relief here. And it's also in its plastic. We've got a Carson City silver dollar. It's in a big case. It looks like it's 1884. Pretty standard there. We'll be able to test that. That looks like it might need a wand given how big that case is. And then finally, we've got this big piece. 50 ounce troy silver bar from Apmex. And it looks like someone wrote on it. That won't interfere with our readings at all. And we're going to have to test this on that external bridge, see how that goes. Okay, let's get started with our testing. I think up first we're gonna test this 1 ounce pure silver piece, which means we need to power on our Pro. It's going to turn on, show us the version and everything, and then it's going to ask for calibration. It does that every time it turns on. That's just to ensure that all the internals are working correctly and that the temperature sensor is properly calibrated. So you can see each light illuminates showing each sensor is being calibrated, and it's ready for us to place our sample. Now this is a 1 ounce pure silver piece, which means we need to change our metal and our weight here. So I'm going to click metal, I'm going to click over to silver, it's on pure, I'm going to select pure, and then I'm going to click onto weight. And it's on English units, ounces troy. So I'm going to go down to just 1 ounce troy. Click enter. Now we're ready to take our measurement. So I can measure this even through its case, and it should be the right size to measure on our large sensor. It entirely covers that black circle. And as you can see, the readings are coming up as good. We've got 2 blue arrows, which means the readings are reliable. This top one is the surface reading, checking in and near the surface of the sample. It's coming up in the green at 1.60. And this bottom one is also a blue arrow, meaning it's reliable. This is the through reading, meaning it's checking the bulk of the metal, making sure the interior doesn't have any foreign metals. And it's also at 1.6. So they're both spot on, right in the green. We are all set with this piece. Let's continue our testing with these 2 1-ounce silver maple leafs. One of them is from 2014, one of them is from 2011, but they would still test the same. They're still pure silver in 1 ounce, so our device is all set up and ready for that. Let's start with this one. And that entirely covers that black circle, but uh-oh, we got some bad readings on there. It looks like we've got blue arrows, meaning we've got reliable readings, but they're both off the scale to the right. And to the right means more resistive than expected, to the left means less resistive than expected. So these are off the scale to the right at 6.6 and 6.77. I don't know what's in that one, but it doesn't look like it's silver. Let's try reading it from the other side, just to be safe. Yeah, similarly bad readings. That looks like a problematic piece to me. Let's try this other one. The other one comes up just about in the range. Let me make sure it's centered and covering that black circle. Yeah, 1.62 on the top reading, 1.63 on the bottom reading. So both the surface and the through reading are turning up good, and we've still got those blue arrows, meaning we've got reliable readings on both those. Just to be safe, we can flip it over and see that both sides are giving us the same thing. Now, it's unnecessary to flip it over, especially with that through reading, but just to demonstrate how the device works, it's nice to show off. I'm also going to try sizing these. Now, these are the same size, just about, but I want to show how the device actually sizes them. So if we put this one under here, and we click dimensions, it'll ask if it's round or rectangular. This is a round piece. I'm going to press round. And this bar illuminates to show us we should line up one side of the coin there, and then the other side of the coin should fall somewhere in that green range. And as you can see, it does that. It's a little hard to tell through the lights on the plastic, but it is falling in the green range, and in fact, they both are, which means whatever counterfeit metal they used in this piece here is the right density, but it's the wrong resistivity. So this would pass any size and weight test, but it's failed our resistivity test. Our Pro device was able to catch that one as a bad piece. Okay, following up those silver maple leaves, we're going to try these gold maple leaves. Now these should be pure gold. Again, we've got 2 of them. I kind of think one of them is going to be fake. Let's find out. To get out of this dimension mode, we just press that measure button again. Now it's set to silver, so we got to switch it over to gold. I'm going to press metal, click over to gold, click up to pure gold, select that, and it's already set at 1 ounce, and these are 1 ounce pieces. So let's try measuring them. And again, that black circle needs to be entirely covered, and these are a little too small to cover that black circle, so I'm actually going to use the smaller sensor to read them, just to be safe. And if we fit that under there, you can see the light is illuminated, so it is using that sensor. This first piece is coming up well within the range. We're getting the blue arrows on both the surface and the through reading, 2.22 on the top and 2.22 on the bottom, fluctuating between 2.21 and 2.22. That's expected. There's ever so slight fluctuations that happen. I'm going to test the other one now. As I move that over again, that light is illuminated, and we've got some bad readings here. The readings themselves are reliable. We've still got those blue arrows, but the numbers are way off the scale, 4.87 and 4.1. The good coin was reading at about 2.2. Now we've got 4.8. So yeah, I don't know what's in this coin, but it is not consistent with pure gold. We could even size these as well, just to confirm. If I click this dimensions button again, they are round, and that same effect. We're going to see a 1 line illuminated and a green range, which it should fall into. The good coin passes, and the questionable coin also passes. And that just means that whatever they've used in there does match the density of gold, but it doesn't match the resistivity. So it would pass that size and weight test, but it has failed our resistivity test, so we could identify that coin as bad. Let's move on to the next one. Okay, following up those gold maple leafs, we've got these gold Krugerrands. Now, Krugerrands are 22 karat balanced copper. These are both 1 ounce pieces, so we're gonna have to change the metal real quick. Let's do that. Again, I just press measure to get back to the screen. Then I'm gonna press metal and go down to 22 karat balanced Cu, balanced copper there. Click enter. It's ready for us to test. Because again, these are a little small, I'm gonna test them on the small sensor. Just make sure we've got a good setup there. Okay, this one is looking bad already. We've got blue arrows indicating a reliable reading, but they're way off in the red, and they are now not resistive enough. Again, to the left means not resistive, to the right means too resistive. So here we can see they're way off the scale, 5.59, 5.27. I don't know what's in that one, but it's definitely not 22 karat gold. Let's try the other one. Put that other one on there, they settle down a little bit, and much better. We're getting 9.9 and 9.67 blue arrows again, so we've got a reliable test. And yeah, you can see that this one is testing well within the range, and the numerical values are actually double what that bad one was testing, so that bad one is, yeah, really bad. We flip it over just to double check. 10.18 on the top and 10.08 on the bottom. The surface and through readings are consistent. I think this one's our bad one, this one's our good one. But let's size it just to double check here. Gonna click measure. They're round. Do the same thing. Align it. And yeah, right in the range. It's falling in the green. Flip it around. Test the other one. Again, falling right in the range. So whatever metal they used would pass the density test. It's the right size and the right weight, but it's the wrong resistivity. So a good catch there. One good Krugerrand, one bad Krugerrand. Okay, we're gonna stick with the coins here. We've got this 1/4 ounce Monarch Precious Metals pure gold piece. And we're gonna have to change our metal setting here. See if we get a good image. So I'm gonna switch it back up to pure gold. And then I'm also going to go ahead and enter the weight as 1/4 ounce. And this is definitely too small to read on the large sensor. I'm going to try reading it on the small sensor. Okay, so our device is asking for calibration. It does that periodically, especially when we're under, hot lights, just to be safe, just to make sure everything's testing properly. So I've removed all the samples, and I'm going to press the calibrate button, let the device calibrate, and make sure everything's working as it should. Very important right now while we're checking for counterfeits. So let's put this on here now that it's calibrated. Make sure that's fitting under the sensor. And as you can see, the surface reading on here shows it as in the green, but the through reading is problematic. We're getting blue arrows on both, so it's reliable, but that through reading indicates that that's not pure gold throughout. The bulk of the metal is some other alloy. I don't know what it is, but it's definitely not pure gold. If we want to really be safe, we could flip it over just to double check. We flip it over and put it under there. It's even deeper in the red now. So, continued problems. And I will say, with a surface reading in the green, a piece like this, it might pass the small wand, it might pass the PMV original, but the Pro and Pro Mini with their through readings, they're going to catch that right away, and they just did, as you saw. I'm not even going to bother to size this one. It's already questionable in my book. I'm going to count it as a bad piece. Okay, we're still here with the pure gold. We've got this piece. Now this one's interesting because it actually tells us that it's gold clad. So we're just going to see how that shows up on our device, even though we know what's in there is bad. If we try it on the large sensor here, it just doesn't quite fit because it's not covering that black circle, and it's too large for the small sensor. So I'm going to break out our large wand, that should at least get a surface reading for us. All I do is I plug in the wand here on the right side, and it's going to ask for calibration. That's just to check the sensors. Press calibrate, and I cleared the device of all samples, and I'm keeping the wand at least an inch away from any other metal to make sure that it properly calibrates, and already it's done calibrating. I'm going to take our piece here, and you just hold it against the face of the metal like this, but to give you a view of the screen, I'll put it down. And look at that. We've got way out of the range at 219.24. That's incredibly high. Definitely not pure gold all the way through. We're seeing right through that clad. If we flip this over, oh, now it's up at 565. So yeah, whatever's in there is definitely not pure gold. All right, we're gonna go back to silver here. I've got this 1875 90% silver piece. It says it's a 0.900 fine, which means it's 90% silver. And I don't need this piece here anymore. And I'm gonna leave the wand plugged in. It shouldn't affect our readings at all. But I do need to change the metal to silver pre-1900 because this is from 1875. But that pre-1900 setting takes into account, you know, more contaminants and things like that that were present at the time of manufacturing, you know, back in the 1800s. So this coin may or may not fit on the large sensor. Let's see how it reads. Well, it does fit on there, but you know what I forgot to do? I didn't enter the weight. Let's enter the weight first. So I'm gonna go up to 1 ounce. Okay, now we're ready to take our readings. Slide that in there. And look at that, it's way off the scale, both top and bottom. We've got blue arrows, meaning reliable readings, but it's nowhere close to the range. 10.45 on the through reading and 10.98 on the surface reading. So we know that that's not just surface contaminants that's causing that. That means that both the through and the surface are bad. If we flip it over, try reading from the other side, hold it down, keep it flat, equally bad. So definitely a problematic coin. Someone really tried hard to make it look heavily circulated, but that's not going to fool us because we've got the PMV Pro here. Okay, so sticking with our 90% silver coins, this is a 1884 Carson City silver dollar. These are 90% silver, 10% copper, so we can leave it on that same setting. It's also pre-1900. Now with this big case, it's not going to quite fit under our sensor here. It's thin enough, but it just won't entirely cover that circle. So we're going to use the large wand again, and I'm just going to place that down and take that wand reading to measure. And it looks like it's coming up in the green. We're getting a blue arrow, so it's getting reliable readings. And it's right in the green range. I'm going to move the wand around a little bit just to make sure we're getting some consistency. Yeah, it seems like it's the same throughout. I'm going to flip it over, measure from both sides just to be safe. Yeah, it's in the green, 2.04 on the backside here. And the last step would be to size it and weigh it. Weighing it might be a little difficult given this case, but you might be able to calculate that out. And then sizing it, you just use some calipers to make sure it's the right size. But this is at least passing the resistivity test. Okay, so sticking with our silver, we've got this 10 ounce pure silver bar here. It looks like it's 3.9 fine. Might have been from Ohio Precious Metals. Maybe that's a owner of Provident Metals. But we're going to test it. So first of all, I got to change my metal up to pure silver. And this is a 10 ounce bar. So I'm going to change it, change the weight to 10 ounces here. And let's test it. It'll test on the large sensor here. Now our setting, our pure silver setting, is calibrated to put 4.9 silver in the green and 3.9 silver in the yellow on the right. And we do that because we so frequently see 3.9 silver counterfeited that we just want people to check the other aspects, like the size and the weight, which we'll check the size here in a moment. So top reading 1.67, blue arrow, good sign. Bottom reading, the bulk resistivity, blue arrow again, 1.61. a good sign throughout. I'm going to move it around just to make sure we're getting consistent readings throughout. Okay, it's fluctuating a little bit, but not out of the range, which is fine. And let's try sizing this piece. So I'm going to press measure here, and it's a rectangular bar. So I'm going to move this down. This line is illuminated, so I'll align this side here. I'm going to align the top of the bar with this horizontal dotted line. And it looks like it's just about aligned there. Like that. And then I'm going to adjust the width. It might be difficult to see on the video because of the reflections, but I'm just adjusting the width to match the width of my bar here, and the end should fall somewhere in the green range, and it does. So that bar is the right size for that. So it's passed our resistivity test and it's passed our sizing test. So I think this is a good bar. Let's get out of that mode. Okay, so we're going to now test this Pamp Suisse 1 ounce silver. It's also 3.9, so it should fall in the yellow just like that other bar. Now this is in the assay, which we can test through, but that's no longer a guarantee that these are genuine. So let's see how this goes. And actually first I'm going to enter the weight down to 1 ounce just to make sure it's matching this. Now if I put it on here, it doesn't actually cover that black circle, so I'm going to switch this over and measure on the small sensor. It still fits under, that's a great sign. And it's 3.9 silver and it's falling in the yellow, so 1.75 and 1.7273. That's looking good for now. We're getting blue arrows, meaning a reliable reading. I'm going to move it a little bit just to make sure we're testing all sections of the bar. Fluctuates some, but not out of the range. Gets a little close in some parts, but it seems to be okay. But now let's size it and make sure it's the right density, and that's why we have this yellow range, to remind users to size it. So let's size it right now. And it's a rectangular piece. I'm going to do the same thing. I'm going to align it to this illuminated bar, to this corner right here. You can do that through the plastic. It's a little hard to see on the video, but I'm going to try to adjust the width, and wow, I've already adjusted the width, and the green is here, and the bar goes all the way out here, so this bar is way too big. So it passed our resistivity test, but it failed the sizing test, which means it is definitely not pure silver. This might be a copper alloy or something like that. I don't know what's in here, but I know it's not pure silver. So this is a bad piece. Okay, I'm going to get out of our dimension mode. And up next we've got this 5 ounce pure silver Panda from 1994. It's in its capsule, shouldn't be a problem for us to test. I am going to change the weight up to 5 ounces there. And definitely won't fit under the small sensor, but it will fit easily under the large sensor. So let's test that, and oh man, already a bad sign. We're getting blue arrows, meaning we've got a reliable reading, but it is well outside of the range. 5.91, 5.82. Our yellow cutoff is 1.8 on pure silver. So this is well outside of the range. But just to be thorough, let's try moving this around. Yeah, there's, no matter how you measure this, yeah, it's a bad piece. We're getting now 6.1, 6.2 almost on there. So definitely a bad piece. Just for fun, let's size it, see if it's the right density. It is a round piece. So I'm going to align the right side up to this illuminated bar. The left side should fall somewhere here in this green range. And wow, look at that. It is way too big as well. So this piece is not only the wrong resistivity, it's also the wrong density. Nothing about this is correct. I don't know what's in here, but I know it is not pure silver. Okay, so for our final piece here, we've got the big one, the 50 ounce pure silver APMEX bar. Now this piece is just too big to fit on the onboard sensors. This bridge can handle anything up to 12.5 millimeters thick, and this measures at about 15 millimeters thick, so it's just too big, which means we're going to have to attach our external bridge to get a reading here. So I'm going to go ahead and do that. Okay, I've got our external bridge plugged into our device here. I'm going to press calibrate. It's going to check all the sensors, make sure everything's working. And you can see the lights illuminating, making sure everything is working as it should. And when I calibrate, I have this plunger raised all the way up, and I have no samples anywhere on the device to make sure it properly calibrates. So I'm going to place this on here first. It's already set to pure silver, but I do have to enter this as 50 ounces into our weight here. So I'm going to click up to 50, properly set. Now I'm going to place this on our external bridge, and as soon as I do so, the external bridge becomes active, and it asks us to enter the width. Now the width of this bar is already 75, so I've already got that entered. And now I'm going to click measure, and I'm going to press the plunger down until it's touching the surface. And let's wait for it. Okay, now it's taking some measurements. We're getting blue arrows, both on the surface and the through reading. This is a 3.9 fine bar, so it should be falling somewhere in the yellow range. So far so good. Let's move it around a little bit, make sure it's testing everywhere properly. Just like on the main device, this external bridge has a circle that needs to be entirely covered the whole time, so I'm sure to not uncover that circle while I'm moving the bar around. And as I do so, yeah, the settings are all coming up as good, but we can still size it. Let's try sizing this, make sure it comes up as the right dimensions. So I'm going to press dimensions here. The width is already entered as 75, and it's telling me the minimum length is 116.8 millimeters and the maximum is 137.6. So we calculate that based on the density of silver, and we account for maybe some bevel or angled sides, that kind of thing. But with those, I can now just confirm that it's the right size, pull the plunger up, move the bar to the included scale, and look at that, it comes up right around 125. I want to make sure I'm lined up properly there. Yeah, closer to 126 or so, which is within our minimum, within our maximum and above our minimum, meaning it's the right size. So that looks like a good bar. So that's it. Those are all the precious metal coins and bars we were sent. As you can see, we were able to test everything, gold, silver, in its case, out of its case, no problem. Some of them we had to use the wands, some of them we were able to use the external bridge. And using the Pro's many methods of testing the surface, the through reading, and the dimensions, we were able to catch all the counterfeits that are here. You know, things that you wouldn't suspect, things like this, where it looks perfectly good. You know, it passed our resistivity test, it's just the wrong size. So this could easily slip by someone who's maybe not as accustomed to looking at bars like this or isn't sizing them. Up to things like this, where the two pieces are the exact same size, they look just about identical. The only thing that identified the fake was the resistivity. And then, again, pieces like this, where the surface reading came back, this was very thickly plated with gold, but the through reading showed that whatever's in there is not pure gold, so this isn't a genuine piece. So that's really the power of the Pro, is being able to read anything that comes across your table. I mean, we could have gone up to 100-ounce bars. We don't have any, you know, 1/10 ounce or 1/20th ounce pieces here, but we could have read those as well, and everything in between. So really the Pro is the perfect tool for coin shops and, you know, professionals who are looking to thoroughly test every sample that they've got. It's really the only tool for the job. Thank you for watching the Sigma Metalytics Precious Metal Verifier Pro video. To learn more, please visit our website at sigmametalytics.com. There you'll also find user manuals, technical guides, coin resources, and more videos.